Hello students, welcome back. Let us start with the chapter. I have started with this chapter, Applications of Derivative. I have taken 4 lectures. This is my 5th lecture. In 4 lectures, what we have done is 4 different types of applications. First one we did is problem based on equation of tangent normal. Second was based on rate measures. Third application was problem based on displacement, velocity, acceleration, and jerk. Fourth application we did was approximations. Okay, so these are the 4 applications we have done. That means we have covered 2 types. Type 1, which includes this first three applications, and type 2, which includes approximations. Now there is type 3, which I'll be doing it later on. That is problem based on Rolle's theorem and Lagrange's mean value theorem. That I'll be taking in the next lecture. The 4th type that we are doing it right now is the 5th lecture is based on 4th type, problem based on increasing and decreasing functions. That is 6th application, you can say. Okay, so let us understand what is increasing and decreasing functions. Function is increasing or function is decreasing. Okay, let us understand about it. Here you can see that definition as well as the diagram and the explanation for that. First, let us understand the diagram here, then we'll go to the definition. As you can see in the diagram, the function is, you can see it is increasing function. Now, as we are considering the function for a particular interval from A to B, that is from A to B, the value of x increases. Say x1 and x2 are 2 values taken in between. The value of x increases, and by taking the value of x in that function, the value of function also increases. As you can see, the value of function also increases, right? So that is, the definition says here, a function f is said to be monotonically, or you can say strictly increasing function on an interval a comma b if there exist 2 values x1, x2 in that interval a comma b with x1 less than x2. That means the value increases from x1 to x2. The corresponding value of that function, when we put in that value of x in that function value also increases. That is f of x1 is less than f of x2. That x2 gives you a more value than x1, right? So here it shows that the function is increasing. Now they are using this term monotonically, or you can say strictly. It is seen that the function is gradually always it is increasing form, and that is why we say that it is monotonically or continuously increasing function. Okay, so here for that we need some condition to solve the problems. Now to solve the problem, जो condition हमें find करना है, it is explained by using this particular example here. Let us take a function f of x in that interval a comma b and assume a small h, which is a positive number or a greater than 0, which we say that it is a small increment in x. That means if I am considering increment in x, there is another term x plus h, which is a value greater than x. Okay, so x less than x plus h is taken here. That x represents a smaller value, that is x1, and x plus h represents the greater value x plus h. Okay, so according to the definition, as the value of x increasing, function value also increases. So f of x is less than f of x plus h, or in other words, interchanging the terms will give me what f of x plus h is greater than f of x. Now taking the terms on one side and dividing this by h, as you know that h is the small increment in x, h is a positive number, we can divide both the side by h. So here that 0 remains as 0, and taking limit as h tending to 0, we get this limit of f of x plus h minus f of x upon h, and on the right hand side, as it is 0, right, you can say it is limit of that 0 is 0 only. Here this represents, the left hand side here represents what? It is derivative by first principle, or you can say it is the definition of derivative. That is, we define f dash x as limit h tending to 0, f of x plus h minus f of x upon h. So I can write this as f dash of x. Now here, by taking that limit, the sign we say that it is greater than equal to 0, because it may come out to be 0, right? So here the numerator can also be 0. Okay, so here we say f dash of x is greater than equal to 0. Now let us see in this function that curve in this diagram is gradually, you can see it is increasing. Now another way you can explain this condition is, if I draw tangent at each point between A and B on this curve, the tangent will always make an acute angle with this positive x-axis. Now acute angle means that is an inclination with positive x-axis, right? That is, inclination is always acute, and for which we say that the slope of that line having acute angle will be a positive value, and slope of that line is slope of tangent for this particular curve. So in that interval A to B, tangent will always be having a positive slope. In the first step, में जो किया था, we have defined that slope of tangent to a curve as f dash of x, or you can say dy by dx. So here we say that for this particular interval A to B, that function is increasing if the slope is positive. Slope of tangent to that curve in that interval is positive, and that also we say that it is greater than 0. F dash x greater than equal to 0. So this is the condition for the function to be increasing. Okay, so this is the first part. Now let us understand about the function decreasing. Okay, so let us see that next. That is decreasing functions. Now you can see that graph again. Here, if you see, the graph is decreasing term, right? Decreasing is as the value of x increases, value of the function decreases. Changes means if x1 less than x2, f of x1 becomes greater than f of x2, right? So the function here is defined in this particular form. So here the value of the function goes on decreasing by increasing the values of x. Okay, now the explanation is almost the same as the previous part of it, increasing, only the sign changes here, because that f of x1 is greater than f of x2, f of x plus h is less than f of x here, and accordingly by taking limits and all, we are getting f dash x as less than equal to 0. So this is the condition for that function to be decreasing. And again, if you consider tangent at each point on this curve between A and B, the slope, or you can say that tangent, makes obtuse angle with the positive direction of x-axis. That shows there is a negative slope, right? The slope of the tangent to that curve is going to be negative, less than 0. That is, f dash of x is less than 0 when the function is decreasing. So here we are getting conditions that for increasing and for decreasing functions, f dash x is greater than equal to 0 or f dash x is less than equal to 0. Now here that note is given, just understand about this point, whether here function is increasing or decreasing at a particular point. Sometimes you get f dash x is 0. That shows f dash x is 0 means the slope of tangent is 0. That shows what? That tangent becomes parallel to x-axis. So there are 2 points where that function or f dash x is 0, where you can say that tangent becomes parallel to x-axis. There are 2 points. One, at the point where it is the function is having its minimum value, and the other, the function when it is having its maximum value. So that point we are going to use for the next type, okay, for maxima and minima. That is the last type of this particular chapter. That will be using in that. They are the extreme points. So in general, there are 2 conditions to be used here. They use increasing decreasing function, or sometimes they say monotonically or strictly increasing or strictly decreasing functions. For increasing decreasing, we consider greater than equal to, less than equal to sign, and for monotonically increasing or decreasing condition, we use greater than and less than sign without the equal to sign we use. That is what strictly we are following here. these conditions for the problems here. Okay, so this is the explanation to understand what do you mean by function is increasing, function is decreasing, and the condition for the function to be increasing and decreasing. Okay, so let us apply this to different sums for this particular type. Let us start with that. Okay, so let us start with that first example. Question 1 is, show that the function f of x, which is x cube plus 10x plus 7, where for x belongs to real numbers, is strictly increasing. हमें prove करना है that function is always increasing type. Okay, so always increasing shows what we are supposed to prove that function f dash x is strictly means always greater than 0, not greater than equal to 0. Okay, let us start with this. So let us start with that function f of x is x cube plus 10x plus 7. We differentiate that with respect to x. What is the derivative of that? X cube, 3x square, 10x is 10, and constant 7 is 0. So that gives me f dash of x is this 3x plus 10. Now, as you know that the two terms we have in this function, that is f dash of x, has two terms. One is 3x square, the other is 10. Now let us consider x square. We know that x is a real number. X belongs to R as it is given in here. X belongs to R. You take any real value of x other than 0, the square will be a positive value. And if you consider 0, it is 0. Okay. So that means x square is always going to be a value greater than equal to 0. That shows 3x square is always greater than equal to 0. And 10 is a positive number, as you can see. So if I add the two, the sum of the two will always be greater than 0 now. Okay, so 3x square plus 10, I can always say that it is greater than 0 value. And that shows that f dash of x is always going to be greater than 0. Now you take any real value of x, I'll get f dash of x as always greater than 0. That shows what? That this given function is always, or you can say strictly increasing type of function. Okay, so that's, you can write answer, your answer as it is strictly increasing function. Okay, so let us understand the next sum now. Let us go to the next is, question is to test whether the following function given is increasing or decreasing for all real values of x. The function given to you is x cubed 6x square plus 12x minus 5. Again, to check whether it is increasing or decreasing, we need to find f dash of x, and we need to check whether it is going to be a positive or a negative value. Let us check for that. Let us consider the function. Okay, so differentiating with that with respect to x gives me x cube derivative is 3x square, 6x square derivative is 2x into 6 is 12x, 12 into x derivative is 12, and constant derivative is 0. Okay, so 3x square plus 12x plus 12 equal to 0. Is equal to, now by taking 3 common, what I'm getting? X square plus 4x plus 4, and that's a perfect square. You can see in that bracket x square plus 4x plus 4 is the perfect square of x plus 2. So that gives me what? 3 times x plus 2 the whole square. That is what f dash of x we are getting. Now let us consider this x plus 2 the whole square. Now x is a real number. Now if I take x equal to value other than minus 2, value of x, if I take other than minus 2, x plus 2 the whole square will give me answer as positive. Any real value other than minus 2 will give me a positive answer. But if I take minus 2, I'll get 0. That means x minus 2 the whole, x plus 2 the whole square is always greater than equal to 0 for all the real values of x. That means 3 times of x square plus 2 will always be a positive value for x not equal to minus 2, and in general we say that it is greater than equal to 0 for all the real values of x is given here, right? So f dash of x क्या मिल रहा है हमें? Greater than equal to 0 आ रहा है. So here I cannot say that it is strictly increasing, right? Comes out to be 0 shows that there will be a change in the value here. Okay, but for general we say that this given function will be increasing, right? So not monotonically or strictly increasing, because you are getting 0 also. So here that function is increasing for all the real values of x. We are not using that term monotonically or strictly. That is the difference between these two sums. Now I have explained you this two sum in which we are getting positive values. You may get negative values here. The negative value that shows that value of this function will be either less than 0 or less than equal to 0. Okay, and if it is less than or less than equal to 0, that shows that it is going to be monotonically or strictly decreasing or decreasing function. The method remains the same. The type of function only will change. The steps and everything will remain the same. Okay, so I'm giving you a few sums for homework. Okay, next is questions for homeworks are, or for practice are, you can say that functions are given x cube minus 6x square plus 12x minus 16. For x belongs to real number, check karna hai. Second also you can see. Third, x minus 1 upon x is there. You can differentiate and simplify accordingly. Check whether that function is greater than f dash of x is greater than equal to 0 or greater than 0, less than equal to 0 or less than 0. Okay, accordingly you can write your answer. Okay, then this is one type of question they ask to check whether it is increasing or decreasing function. Okay, for the given values of x. We go to the next now. Let us see that next sum. It is check karna hai or find the value of x, sorry, for that function for which the function is monotonically increasing, or you can say monotonically decreasing. For these two conditions, we want the values of x. Now the function is x cube plus 12x square plus 36x plus 6. For considering increasing, decreasing, we need to consider the derivative. First derivative is to be taken. So let us take the function differentiating with respect to x gives me derivative of x cube is 3x square, 12x square is 24x, 36x is 36, constant is 0. 3x square plus 24x plus 36. Taking 3 common gives me x square plus 8x plus 12. Now you can factorize this. It is not a perfect square, but you can factorize it as, right? Both are positive terms, so factors are also positive. Sum is 8, product of the two term is 12, gives me two factors as x plus 2 x plus 6. Okay, so that's your f dash of x. Now we want values of x for which this is f dash x is positive and negative. Monotonically this term is used, right? So let us take the first condition. For function f of x to be monotonically increasing, we need f dash of x greater than 0. Now, what is f dash of x we have? That is 3 times of x plus 2 x plus 6 we have. We want that to be greater than 0. As 3 is positive, by dividing with a positive number, the sign does not change. It remains as greater than 0, gives me x plus 2 into x plus 6 greater than 0. Now understand, product of two numbers positive greater than 0 means positive. When you can say the product is positive, there are two conditions, right? There are two conditions for which the product of two number is positive. First, either both are negative, product is going to be positive, or both are positive, then the product is positive, right? So there are two cases to be considered. One, either both are negative, that is less than 0 taken, or the second condition is both are positive or both are greater than 0. Okay, so let us take now. I have taken a number line in which you're getting two values of x from this. Is one is -2, another is -6. Now, when I put two values of x in that on that number line, -2 and -6, as you can see, we are dividing that number line into three intervals. Between minus infinity to -6, between -6 to -2, and then from -2 to positive infinity. Like that, we are getting three intervals. Okay. Now, by assuming some values in this interval, you get the values of this product. So, by assuming some value less than -6, between -2 and -6, and greater than -2 up to infinite, right? You can check whether that product is going to be a positive or negative value. So here I've written here that in this interval I'm getting positive. In this interval I'm getting the product as negative. In this interval I'm getting product as positive. You can assume some value. Say it is between -2 and -6. You can take -3. So if you put minus 3 in this product, minus 3 plus 2 is minus 1, minus 3 plus 6 is plus 3. Here we are getting negative, here we are getting a positive value, that means the product is negative. That shows that in this interval, whatever x you take, the product of this number will be a negative value. Now you take value less than minus 6, you take minus 7, minus 7 plus 2 is minus 5, minus 7 plus 6 is minus 1, both negative, product positive. Greater than minus 2, I can take minus 1, 0, 1, any value of that. So that will give me, say if I take 0, I'll get 2 and 6, both are positive, product is going to be a positive number. Okay, so here just by considering two values of x in this number line, we are getting interval and you can check where it is positive, where it is negative. That makes your sum easier. To get the answer, it becomes easier by this number line. Okay, but we need to write. Okay, kaise likhna hai, let us understand. So here we are considering that case 1 in which we are taking both value as the first case, both value we are taking is negative, less than 0 here. Okay, so x plus 2 less than 0, x plus 6 less than 0. So x less than minus 2, x less than minus 6. Now less than minus 2 and less than minus 6, both are in the same direction. But less than minus 2 have two possibilities. One, in this interval we are getting negative and here we are getting positive. But if I consider less than minus 6, it is always increasing. It is always positive number. So here we say that between these two, I'll consider x less than minus 6. Then for this value of x, the function is always going to be, this product will always be a positive number, which is monotonically increasing here. There is one more condition for which we are getting that value of this is positive, and that will come in the next case. You can see that second case in which we are considering both positive, both greater than 0. So x greater than minus 2 and x greater than minus 6. Now if I consider greater than minus 2, it is giving me positive value, but greater than minus 6 has to both the values, right? I want only monotonically, means always increasing part, right? So I'll consider what, x greater than minus 2 from this, for which that product will always be greater than 0. That is monotonically increasing. So from two cases we are getting what, x less than minus 6, here x greater than minus 2. For these two conditions, the first condition from both this, we are getting f of x is monotonically increasing for only if both are satisfied. Now, as you can see, there are two different intervals. One, this interval is considered as minus infinity to minus 6, and this interval is considered as from minus 2 to positive infinite, for which the function is increasing monotonically, right? For these intervals, function is monotonically increasing. So ये तो हो गया case 1, first case for which we got the value of x as these two intervals. Now we know the answer now for the next, that this interval is going to give me the product negative. So let us take the next example, next case, that is for function to be monotonically decreasing. So what condition we have? Let us simplify that. For f of x is said to be monotonically decreasing if f dash x is less than 0. Okay. So we have already taken the derivative. We have 3 times of f dash of x as 3 times x plus 2 x plus 6, and we want that to be less than 0. So again, by dividing by 3 positive number, the sign remains the same, less than 0. So x plus 2 x plus 6 negative. Only the condition changes here. Because we want the product to be negative, we need to consider one positive, one negative number. So again we have two cases. First case, I'm taking x plus 2 negative, less than 0, and x plus 6 positive. And the second case, x plus 2 positive, x plus 6 negative, right? So here again, first, as I've already explained, that between minus 2 and minus 6, the value of this product is negative. Let us do it case wise. The first case, in which, as I said, is that one is negative, the other is positive. That gives me x less than minus 2 and x greater than minus 6. Less than minus 2 towards this negative side, and greater than minus 6 toward positive side. That shows the interval between minus 2 and minus 6. So here both satisfies the condition. So here we can say दोनों condition एक ही case में आ रहा है, right? Here x, for x belongs to minus 6 to minus 2. It is always from negative to positive direction. Okay, function is monotonically decreasing. Okay. Now the second case, Second case में क्या किया है? We are considering x plus 2 greater than 0, x plus 6 less than 0. Here we are getting x greater than minus 2. That is this case where you are getting product positive, and the other is x less than minus 6. There also you can see the value of the product is positive. So we don't have to consider. So in this case, this case does not arise. Check why. That is what I have explained you. That there in these two intervals, we are getting the product as positive. So discarding these values of x. Directly from the first case, we are getting the answer, right? So finally, we are writing the answer as what? Function is monotonically increasing for all x in the interval minus 6 to minus infinite and minus 2 to plus infinite. This interval function is increasing, and for this interval between minus 6 and minus 2, it is monotonically decreasing. Okay, so that is the answer, final answer for this particular sum. So here, let us see some questions for you to practice. Similar questions for practice. I'm giving you few questions from the textbook only. You can take it from the textbook or you can see it from here. I'm giving you functions in which you will be following the same condition. Question here, they are strictly increasing here and strictly decreasing. You are supposed to find the values of x. So like that, in exam also, you may get only one condition. Okay, one condition itself will carry 3 marks. I have explained you both the condition in the same sum, but in general, they are asking you to find the value of x for function to be increasing, for function to be decreasing separately. Okay, now let us take some typical sums other than this one what we did. Okay, we'll go to the next sum as this. Find the values of x for which the function is increasing, decreasing. The previous sums what we did, it was written strictly increasing, strictly decreasing, or monotonically increasing, monotonically decreasing. So we are not considered equal to sign in that. Okay, so here in this type, we need to consider greater than equal to and less than equal to sign. Only that difference is there. Otherwise, the sum is solved in the same manner, you can see. Okay, let us take that function, differentiating that with respect to x. X cube derivative is 3x square. 12x square, it is minus 24x minus 144 plus 0, right? So that gives me that f dash of x. Taking again that 3 common from this equation here, 3 common will give me x square minus 8x minus 48. That factorizing this function will give me what? 2 factors, 3 times here. 2 factors are x minus 12, x plus 4. Okay, so let us take the first part of it, that for that function is said to be increasing for which f dash of x should be greater than equal to 0. You can see that the sign we are going to use here is greater than equal to. Okay, so again, as 3 is a positive number, by dividing by 3 will give me same condition again. Greater than equal to sign remains the same. Product we want greater than equal to 0, positive, or you can say non-negative here. Product non-negative is possible only if both are negative or both are positive. Again, 2 cases are to be considered, but you can see 2 values of x. One is positive 12, other is minus negative 4. So again, by putting this minus 4 and plus 12 on the number line, we are getting 3 intervals. You can check your answer directly. You are getting the answer from this. कहाँ पे increasing है, कहाँ पे decreasing है, you can get it from here. Okay, you can see if you take value between minus 4 and plus 12, from negative to positive, 1 0 is there between the two, right? If I put x as 0, this is negative minus 12, and this is going to be positive plus 4. Product is negative. That shows value between these two, x value between these two gives me this product negative. यहाँ पे वो decreasing है, and if you take value less than minus 4, that is, say if I take minus 5 minus 12 is minus 17, and minus 5 plus 4 is minus 1. Both are negative, the product is positive. And if I consider greater than 12, say if I take 13, right? 13 minus 12 is 1, positive, and 13 plus 4 is 17, that also is positive. As both are positive, that shows the product is going to be positive. हमें आंसर तो मिल गया कहाँ पे वो पॉजिटिव है कहाँ पे नेगेटिव है. लेकिन मैंने बताया वैसे we need to write it. Okay, हमें लिखना है. कैसे लिखना है? जैसे प्रीवियस सम में केस कंसीडर किए थे, दो केसेस, जैसे इधर भी दो केसेस आएंगे. फर्स्ट केस either you can say both are positive, or second case both are negative, right? So here only thing is positive is with equal to sign also, that is greater than equal to 0, and negative means less than equal to 0. Okay, so greater than equal to 0 is called non-negative, and less than equal to 0 is called non-positive. Only that difference is there between the two. By considering this, here the first case you can see both are greater than equal to 0 here, but greater than 12 only will satisfy from the first case, and second case less than minus 4 only will satisfy. Less than equal to minus 4 only will satisfy this case condition. Product positive mil raha hai, product positive mil raha hai. So these are the values of x we are getting from each case, right? So how do we say answer is? We write the answer as what? Here first is increasing for case 1 greater than equal to 12, case 2 less than equal to minus 4, combined together gives me this interval from minus infinity to minus 4, and from plus 12 to positive infinite, right? As we are considering equal to sign, the bracket changes here. See that bracket? It is curve bracket with ending with a close bracket here, which includes minus 4, a close bracket here, and not infinite here, curve bracket here, that shows 12 is included in this. So here this bracket includes the and values here, minus 4 and 12, both are included in this. So that is how the answer is to be written. This is for that function to be increasing. Now you know answer for that when it is decreasing. But still, let us see how it is, right? So here again, for that function to be decreasing, f dash of x to be less than equal to 0. Product is negative we want, less than equal to 0, non-positive we want, right? So again, we have the answer. We know that it is between this minus 4 and 12. This gives me the answer that product is negative, less than equal to 0, you can see. So again, two cases, one positive, one negative. Greater than equal to 0 for this, less than equal to 0 here. Two values of x, right? And second case, x less than 12, x greater than minus 4. Here no values of x in this interval satisfies. This is greater than 12, that is we are getting a positive, and less than equal to minus 4 is this value, which is not, again that there also we are getting the product as greater than equal to 0. So no values of x in this satisfies the condition, but here both the values of x satisfies. So answer क्या मिल जाएगा? In this close interval between minus 4 and 12, including minus 4 and 12, that function is going to be decreasing. So it is written as this, that x belongs to minus 4 to 12. F of x is a decreasing function. Okay, so if you are following the method, understand that this method is just to check your answer whether you are getting positive in what interval, negative in what interval. For our understanding, we are drawing it and understanding कैसे हमारा answer आएगा. Okay, so that two different sums we did. One monotonically increasing, decreasing, and here it is simply increasing, decreasing. There we don't consider that equal to sign. Here we consider with equal to sign. So that difference you just have to keep it in mind. Okay, let us go to the another typical sum. That is, here the function given to you is x upon x square plus 1. Again, strictly increasing, strictly decreasing के लिए हमें x का value find करना है. Start with that function, differentiating that function with respect to x. Now we'll have to follow u upon v rule. X upon x square plus 1 it is, right? For u upon v, denominator में v square, so x square plus 1 the whole square, and for the numerator v, x square plus 1 as it is, derivative of u, that is x का derivative 1, minus now u as it is, x as it is, derivative of v, that is x square plus 1 का derivative is 2x. So that gives me what? X square plus 1 minus 2x square, and plus x square minus 2x square is minus x square. So it gives me 1 minus x square upon x square plus 1 the whole square. Okay, so this is what f dash of x we are getting. Now understand this denominator separately first. Let us see what this denominator represents. For all the real values of x, we know that x square is greater than equal to 0. Right? Now, x square greater than equal to 0 means if I am adding 1 to this, is also going to be greater than equal to 0. Or you can just simply greater than 0 also, it will be enough. So here, x square plus 1 greater than the whole square is also will be a positive value. So it is always a positive number. The denominator of this f dash x is always positive. ध्यान से देखना कि ये denominator always positive है. Okay, now the question is to find x for which function is strictly increasing. So ये condition हमें ध्यान में रख के problem solve करना है. Okay, let us start with that case one. First case where first part where we want function strictly increasing के लिए x का value, right? So f dash x is greater than 0 taken. F dash x we have here is 1 minus x square upon x square plus 1 the whole square greater than 0. As I said, we have a positive denominator. That means if I multiply both the sides by positive, this sign will not change. That greater than sign remains as greater than. So that gives me 1 minus x square greater than 0. This is by multiplying both the sides by a positive value x square plus 1 the whole square. और in general अगर denominator positive है, ratio हमें positive चाहिए ना, तो ratio positive के लिए दोनों positive या दोनों negative होना चाहिए. तो denominator तो positive है ही, तो numerator also has to be a positive number. तो इसलिए हमें एक ही केस आ जाएगा इधर that the numerator is a positive number. 1 minus x square is greater than 0. Taking x square on the other side gives me 1 greater than x square. Interchanging the terms gives me x square less than 1. Right? So x square less than 1 है. ध्यान से देखना कि when we take square root लेने के time x के हमें दो values consider करने हैं. एक positive लेना है, एक negative लेना है. Generally equal to sign होगा तो हम directly plus minus लिखते हैं. But if it is with less than, greater than sign, we don't consider it directly. What we do is we consider positive value separately, negative separately, and for the positive square root, we take same sign. What is here, as you can see, less than sign remains less than for positive number, but for negative number, we consider the opposite sign. So here, x is less than 1 and x is greater than minus 1. For this values of x, you can say that the function is going to give me positive value. F dash x is going to be a positive value. Now, अगर check करना है तो number line के पे देखिएगा. Here we say that x less than 1. Less than 1 is towards the negative direction, this direction, right? And for x greater than minus 1 is towards the positive direction from minus 1. That is towards positive 1. So it shows that it is between minus 1 and plus 1. You take any value of x, you get a positive value, right? So between minus 1 and plus 1, f dash of x going to be a positive value. So there you can say that the function is increasing. So we write the answer here that for f of x is strictly increasing for all x belongs to the interval minus 1 to plus 1. And you can see the other values also from here in that number line. So here these are the values of x for which it is going to be negative, right? So वो भी हमें करना है by taking the second case, second part of it, that for function to be strictly decreasing, क्या आएगा? We want f dash of x to be less than 0. Now less than 0, considering the same condition, similarly you can say this is less than 0. Again we are considering this as positive and we want ratio to be negative ना. ध्यान से देखो ratio negative में एक positive एक negative होना जरूरी है. Now हमें मालूम है कि denominator तो always positive ही है ना. As the denominator is always positive, the numerator has to be negative. That shows 1 minus x square has to be less than 0. Now simplifying in the same manner, 1 less than x square I'll get. Interchanging the term gives me x square is greater than 1. Again, as I said, while taking square root, we take positive same sign, for negative opposite sign. So x square greater than 0, x square greater than 1 में square root लिया तो x greater than 1 आएगा, same sign, and x less than minus 1 because negative it is opposite sign. Okay, so greater than 1 is towards the positive infinite and less than minus 1 is from minus 1 to negative infinite. These are the intervals for which the function is going to be decreasing. So here we write the answer that the function is decreasing for x in the interval minus infinity to minus 1 and 1 to positive infinite. For this interval, the function is decreasing. Okay, तो यहाँ पे increasing आ रहा है, यहाँ पे decreasing आ रहा है, because it is strictly we are not considering equal to sign. Okay, तो ये जरा ध्यान से रखना है, point मैंने अलग से लिख के दिया है. Keep that in mind that we are getting the denominator as positive. So accordingly हमने दो case consider किए हैं, strictly increasing, decreasing. Getting it? Okay, we'll go to the next. Another typical sum, that is, see the question here that function is 3x plus 1 upon 3x. हमें prove करना है that it is increasing for this particular interval and decreasing that for this interval. Between 1 by 3 and 1 it is increasing, and between 1 by 9 to 1 by 3 it is decreasing. Okay, so equal to sign you can see, because it is increasing and decreasing, they may use equal to sign including the end value here. Okay, but whatever that interval is, let us start with that sum. The function given to you is f of x 3x plus 1 upon 3x. By differentiating this with respect to x, derivative of 3x is 3 and derivative of 1 upon x is minus 1 upon x square. So that gives me 3 minus 1 upon 3x square. So that is your f dash of x. This is your first derivative, right? Now let us consider function increasing. Let us find x for which that function is increasing. Now the function increasing के लिए क्या consider करना है हमें? F dash of x to be greater than equal to 0. So I am taking 3 minus 1 of 3x square greater than equal to 0, and then we consider that for x cannot be 0 in that interval, right? Because here we are considering that x square is there in the denominator. That means x cannot be 0. This value can be equal to 0, but x cannot be taken as 0. So 3 greater than equal to 1 upon 3x square. I'll just take x square in the numerator, 3 in the denominator. Cross multiplying the terms will give me x square greater than equal to 1 upon 9. ध्यान से देखना अभी. Again we are taking square root, right? तो square root लिया तो obviously एक positive एक negative आएगा. तो मैंने बताया वैसे positive के लिए same sign use करना है, negative के लिए opposite sign. So greater than equal to goes with the positive and less than equal to goes with the negative value of it. So we are getting x greater than equal to 1 by 3 and x less than equal to minus 1 by 3. For that interval, the function is, that shows what that function is increasing, right? So here, what interval you can see, if I go for a number line, okay, let us check that first. If greater than 1 by 3 is towards the positive direction and less than minus 1 by 3 is towards the negative direction, right? So if you see from minus infinity to minus 1 by 3 and 1 by 3 to positive infinite, that function is going to be increasing. So you can see 1 by 3 to 1, it comes in this interval. ध्यान से देखना, 1 by 3 to 1 comes in this interval, okay, for which the function is increasing, right? So here for this value of x, the function, we say that it is increasing function, okay, because it is increasing in this entire interval. In this interval also that function is going to be increasing type, okay. So that completes the first part of it. जो interval मिल रहा है और जो आपको interval दिया है, it satisfies in that, ना? So that shows that ये जो given function है, for this interval it is increasing. Same way, go for the next, right? For that function to be decreasing, क्या आएगा? F dash x less than equal to 0, 1 minus 1 upon 3x square less than equal to 0, 3 less than equal to 1 upon 3x square less than 1 upon 9. So again, x square less than equal to 1 upon 9 है, square root लिया, positive negative. So here same sign, positive के लिए, opposite sign negative के लिए. So I'm getting x less than equal to 1 by 3, x greater than equal to minus 1 by 3. So here it is in betweenness आ रहा है, right? Less than 1 by 3 towards negative side जाएगा and greater than minus 1 by 3 towards positive. It is between minus 1 by 3 and plus 1 by 3. In that interval, that function is decreasing except 0, because it is from negative to positive, that 0 is included, na? But as you know that 0 cannot be taken here, right? So except that 0, in this interval the function is डिक्रीजिंग, तो ये इंटरवल में फंक्शन डिक्रीजिंग हमें मालूम है. नाउ लेट अस कंसीडर द इंटरवल गिवन इन दिस क्वेश्चन हियर, जहां पे हमें डिक्रीजिंग प्रूव करना है. क्या दिया है? 1/9 to 1/3 and 1/9 to 1/3, यानी both are positive only ना. From 1/9 to 1/3 it is the same interval from here, from -1/3 to 1/3. ये तो हमें दोनों पॉजिटिव ही है ना. 1/9 to 1/3 is in this interval only, and for that 0 is not included in this. So that shows that यहाँ पे in this particular interval the given function is always going to be a decreasing function. Okay, so that proves your condition. For the given intervals, the given function is either increasing or decreasing respectively. Okay, so that completes your this particular type, that function increasing, function decreasing. Okay, so just remember, when they use strictly or monotonically increasing, decreasing, use greater than and less than sign, and when they use only increasing or decreasing, use greater than equal to, less than equal to sign. Keep that in mind. This is very important for this particular type. Okay, that completes your this type. So practice करने के लिए examples दिए हैं नीचे. You can see that similar sums for practice. Functions increasing, decreasing के लिए find करना है x का value, and x का value find करना है for which it is strictly increasing, strictly decreasing. And one more, show that this function x minus cos x is increasing for all x. All x means for all the real values of x. आपको prove करना है that function x minus cos x is increasing. Okay, so this completes your type 4, or you can say application number 6, increasing and decreasing functions. Thank you, students.